Hello, and welcome to the Six Figure Developer Podcast, the podcast where we talk about new and exciting technologies, professional development, clean code, career advancement, and more. I'm John Calloway.
I'm Clayton Hunt.
And I'm John Ash.
With us today is Suz Hinton. Suz is a front-end developer by trade, an open source contributor and enthusiast in her spare time. She likes the web, robots, accessibility, education, and code. Welcome, Suz.
Thanks for having me.
Yeah, so before we get into IoT and robots and all of the things we're going to discuss, could you give our listeners just basically a little introduction to yourself and maybe tell them sort of how you got started?
With computers or hardware in general?
Yeah, with computers and hardware, whatever you'd like.
Yeah. Computers for me when I was a child didn't have like a graphical user interface. So I started programming from a pretty young age just because my first computer was a Commodore 64. So BASIC was essentially all you could do. I think at the time, everyone was already on Windows 3.1 too. So I was a really late bloomer with getting computers in general in my household. So I just really loved being able to write lines of code and then it would output art or sprites or, on the screen, or you could poke registers. So that was always really exciting to me. Then when the web kind of became more mainstream, I realized I can actually start writing markup to create websites instead. And that to me was more exciting because I think I missed the BBS days, which is really sad, but I didn't have the internet during those days. So of course, the next wave that came was websites. So I learned how to program web pages, in markup language and CSS and things like that. Figured out how to get it on some free hosting. And yeah, that was kind of all there was to it. And I didn't realize it was a career, but I ended up, after I graduated high school, ended up getting into this professionally, and the rest was kind of history. So I think that given that I started with the Commodore 64, hardware and low-level stuff has always really fascinated me. I loved being able to poke registers and things. And I sort of felt like something was kind of missing, with computers, even after they got really good. There's something really lovely and knowable about being able to understand a computer on a more basic level. And I think microcontrollers are still simple enough that you can understand all of the different parts that make it up. And you can also just like customize things to your liking by being able to invent new things that work for you rather than something that's off the shelf where someone's assumed what you actually want, I guess.
Okay. And so that sort of like spurred on your interest in getting into IoT and these low-level devices. So what are you mentioned some things that you're working on. What are you working on these days?
Yeah, so now in my spare time, I'm working on a project with the Xbox adaptive controller. I don't know if you've ever actually heard of it. Okay. I have one on my desk. It's really cool. This is what it looks like.
Oh, wow.
And it behaves in the same way technically as like an Xbox One controller. However, this just has much easier to use buttons for people with mobility impairments. You can actually stomp on these buttons because they're pretty hardy, which is really cool. So, but I think that the most compelling part of this is that every single button is broken out into a 3.5 millimeter like audio jack setup. And that's a very simple, I guess simple is sort of like a subjective word here, but it's broken out into basically like an open switch circuit setup. So if you plugged a headphone jack in and connected the ground with one of the signals, whether it's like the left ear or the right ear, that will actually complete the circuit, and that will be basically a passive switch, which is really cool. So I have just a really quick breakout board where I was testing this with a Raspberry Pi. It looks like a complete dog's breakfast. There's not really a way that I can hold it up properly, but that's basically it. There is a transistor and a resistor on there. So the transistor acts as a switch. From here, I want to do things like voice-activated button switches and also like thought-activated ones too. I don't have it handy on me right now, but I have a Neurosity Notion headset, and you can train specific thoughts on it. So it would be really cool to be able to activate buttons so that, if you think about something like a text-based adventure game, that really only has a couple of things that you need to do. And let's say we had this sort of Stephen Hawking style navigation interface where it's just slowly cycling through your options. If you can time your thought to happen as the cursor has cycled to the option you want, then technically you could just use one button to move through a text-based adventure game. So that's the kind of proof of concept that I want to finish and then turn into like a breakout board so people can make extra things with this a little bit more easily than the dog's breakfast that you just saw.
That's super cool.
Yeah, so a number of months ago, Clayton and I run the stpete.net meetup user group here in the Tampa Bay area. And we actually had a full day workshop with the MXChip and IoT devices. And so we actually ran across one of your tutorials and used the MXChip to show some images being passed through Azure into the display there on the chip. What types of thing, like how did you get interested in involved in creating that type of tutorial and things, and what can we do with something like an MXChip?
Well, full disclosure, Microsoft is involved in the MXChip, and I worked for Microsoft, and I was a developer advocate. So I wanted people to have, I guess, something that was beyond the hello world of IoT. And just for those who don't know, the hello world of IoT is basically sending a temperature reading to the cloud and then storing it or graphing it or whatever you want. And it's kind of similar to Arduino, which its hello world is blinking an LED. It's kind of like people follow it and then they're like, now what? You know, they just can't sort of imagine what they want to do with it because they don't know where the boundaries are. They don't know what the restrictions are with what they know and things like that. So I wanted to create an example that shows you that you can do things that might be more unexpected, such as in this example, it's sending a GIF or it's compressing a GIF down to like a monochrome format. And there's only really enough memory for 6 frames. So you can upload a GIF to a website, it'll compress it for you. Then you can send it over basically over the air through Wi-Fi to the device where it will then display that GIF on the screen, memory allowing. So it was really just me trying to show the fun side of IoT and that you don't just have to sort of have these boring graphs because it's necessary at first to learn IoT, but there are so many different interpretations you can have of, you know, the kind of stuff you can do with, you know, contraptions and hardware.
Yeah, I had just as much fun setting up the IoT hub in Azure and configuring that and seeing the messages being passed back and forth. And I think we actually did the hello world temperature sensors being passed back and forth as well. So, you know, there was a lot of fun in doing that. But what are the practical uses other than that? Like you mentioned, you know, these are the fun projects showing the capabilities, but you know, I'm typically a line of business software application developer, so I don't get to do fun stuff. I get to do boring, mundane business tasks. So what are the types of things that these are useful for?
Yeah, I think that's a really good question, but it's also like a really sort of sky is the limit question. If we talk about the kind of, I guess, things that are actually included on this board, maybe we can start brainstorming from there. So we have an audio jack on the top, which is really cool. So you can actually completely not use Wi-Fi, and you can actually use data over audio channels if you want to sort of communicate between two devices. That can be done in certain areas where you can't have an internet connection, and it's not necessary. You just need a bunch of local devices talking to each other, which is really cool. There is like a screen which you can see, even though my webcam is being a little bit, oh, there we go. There's I think we were talking when we were just generally talking earlier, we were saying things like build status for deployments and stuff like that. It doesn't even have to have anything to do with real world sensor values, right? This also has a magnet sensor, so you can sense magnetic fields, which is cool. It also has a bunch of LEDs to use as status lights if you want. It has a microphone, so that's kind of how you can communicate via audio, as well as the audio jack. And it also gyroscope too. So if you put this on something that was moving, such as like a washing machine, you could basically know when the washing machine was done just based on the fact that it wasn't sort of vibrating anymore as it did the spin cycle. So that's a few examples just by touring some of the sensors that are built into it. But there are a lot of practical things, especially around the home, that you could harness, as well as in the office as well.
I was looking at it on Amazon, and I was noticing it has one of the most important things of computer hardware these days is it has RGB LEDs on it.
Everyone loves the RGB LEDs. They're very pretty. It also has an IR sensor too, which is actually really cool. I don't know if it has the IR LED. I don't think it does, but they're really cool LEDs too, because you can basically use infrared signaling with them. So.
Yeah, and before you jumped on, Ash and I were talking, and he noticed that it was like an Arduino, like a Raspberry Pi, just only more expensive. But and I think in you showing kind of the bundle of cables on some of your devices, it's really more about just the convenience of the thing. This is more for prototyping and figuring out what is possible, and then beyond that, it's you get a specific device manufactured. Is that typically how that works?
That's exactly right. And so, this is approximately $40 US. It has a lot of sensors on there, so it's very good value. But the whole point of it is that's a very affordable way, and you can keep recycling it for different prototypes, right? It's a very affordable way to test out an idea and say, does this feel right? And if it feels right, then I'm going to move on to the next promising stage. And even things like the Raspberry Pi, like to me, its fatal flaw, this is like a mess, but its fatal flaw has been that it doesn't have an ADC on board, which is an analog to digital converter. And so all the cables you're seeing here right now, only I think 6 of them are for this microphone. The rest were actually plugged in because I needed an analog to digital converter separately in order for me to measure moisture levels with the moisture sensor that I had plugged into that breadboard as well. So I think just the fact that you can iterate super, super quickly, that feedback loop in hardware is so hard to get down to a really small amount, that's what these boards allow you to do before you then spend oodles of time and money trying to develop your own sort of like professional version of your product.
Okay. And if we're looking at like a $40 investment or something along those lines, and then once you figure out the sensors and the bits and pieces that you need for your custom device, what is the process and look like in getting that manufactured, and what are we looking at price wise when we figure out what it is we need? I'm sure that's all dependent on the types of things that you need it to do, but
yeah, I think that the trademark phrase "it depends" is very relevant here. But I can give you ballparks of stuff when I've just produced like a very low run of stuff, because obviously you start saving when you're doing mass manufacturing and things like that, which is you're not as likely to do when you're first getting started. So depending on how many sort of little devices and sensors and things you actually have, what you tend to do is try to put them all on one printed circuit board. And there are layout packages that allow you to do that on the computer. There's KiCad, there's also Eagle, there's an Altium, there's all these different layout packages. And they're kind of more or less like Illustrator for circuit boards, I guess, where you're defining all the different layers that go on a circuit board. Once you've laid that out, the boards themselves, you can get like a pretty quick turnaround for anything from $10 for 10 boards to $40 for 3 boards if you want something a bit more advanced, or if you want to order something locally made in your own country versus in China. And then the components themselves run anywhere from like a couple of cents per unit to a few dollars per unit. So I mean, I've sort of designed the first custom circuit board I designed. I ordered 3 of them for $40 because I wanted to use OshPark. They have a very good upload and drafting system, so you can kind of see what your board's going to look like. So I ordered from them just because I felt like it was a good newbie option. And then the components themselves cost, I think, no more than $10. So in the end, I spent maybe $50, and I had 3 circuit boards worth of stuff to solder all together. So to me, that's still not a huge setup cost, but if you prototype stuff early, you can save yourself a lot of money and a few weeks waiting for those circuit boards every time, which I think is why prototyping is so important. And then when you start scaling up in mass manufacturing, the costs obviously go down quite dramatically. Again, I've paid as little as $1 a board for something when I've ordered more boards.
Yeah, I've got my Wilderness Labs here that came with its own little breadboard, so
nice.
Plenty of options and things to play around with.
Yeah.
And you had mentioned that you're trying to wrap up one of the projects. Is that the Xbox controller, or was there another project that you're currently working on?
I had another project too that I worked on for a really long time, and then I think I got a little overwhelmed with it. It was actually using the MXChip to prototype with. So do you remember me talking about how there's like a headphone jack and there's also a microphone on this? I was using this data over audio protocol called Chirp. So you can do Chirp IO. And I was basically setting these up in all of my plants so that they could use data over audio to talk to each other. And on the screen, they would sync up with each other. So they would talk to each other. I couldn't understand them. And it was usually, I think I arranged it as like encrypted bits over data protocol too. So I couldn't feasibly like decrypt it unless I knew the symmetric key, which, I did, but still. And what it allowed them to do was to kind of like wake up in the morning and like chirp out their stats audibly. So it sounded kind of like this cute little chorus when I woke up, and then they would do it before when I went to bed as well. And I got all the way through where I laser cut little tree houses to put inside the plants so that they had this little cute sort of little network, and it's sounding very Animal Crossing right now. And then I got to the point where this board was too big. So this massive wires you see right here is me actually trying to downsize it by using the Raspberry Pi Zero W. And I started designing the circuit board for it. I completed the schematic in KiCad, and then I just dropped it. I think I had a few conference talks to give or something like that. So, and now it's kind of this thing where I just have to sort of get over the inertia of getting back into the project, because there are a lot of moving parts on that printed circuit board. I was designing like a hat to go on top of the Raspberry Pi Zero, and it needed an ADC, it needed a MOSFET to drive like a water pump, and it needed the MEMS mic, and then the code for the Bluetooth connecting to the speaker to play the noise was browning out the Raspberry Pi. So I was trying to optimize it from like using too much power. So that whole project is really cool, but it's very complicated. So that's something that I need to get back into as well. Sorry, that was a very long project. All of my projects tend to need a lot of explanation, but that's kind of how I am.
Yeah, I feel like that's kind of how IoT projects kind of tend to go too, though. I don't know, at least in my experience. So in your bio there, you talked about how you love robotics and robots. Do you have any projects or things where you have worked on those things, or is that something that you're looking to do?
Yeah, that's a good question. I'm not as interested in like humanoid robots. I think that they're not inventive, and I don't know why we're trying to reproduce humans. I think we're a very flawed species, and so just like creating the perfect version of ourselves just seems like an oxymoron as well. Things that don't get sunburnt and things like that. I just don't find that engaging. So I tend to be more into, I guess, traditional robotics, which you wouldn't think about, the cute like little humanoid, which is things like 3D printers, of which I have one just over here. That's why I keep looking. And I like being able to optimize machines. And so for a while, I had a little hobby 3D printer, and I was always adding things to it and recompiling the firmware to support different features. I like tinkering with things like that rather than trying to sort of build my own, if that makes sense.
Yeah, no, that makes a whole lot of sense for sure. So you're in your mind looking at robotics from like the sort of almost the industrial side of things, where we're building it to help us complete a process or do something, but we're building the robot specific for that process, and you like kind of optimizing and maintaining for that. No, that's really cool.
So I kind of find myself at a not completely the other end of the spectrum, but more towards the other end. I have a 3D printer and I love it, and I got a whole bunch of electronics sitting on the desk that don't know what to do with. So one thing I'm curious about is how do you get actually started? Like I've got Arduinos, I've got Raspberry Pis. They just sit around collecting dust because I have no idea what to do with them or how to do it. I come up with like big concepts, just as complicated as the ones that you were describing, except I don't know how to do it. so it's like, okay, how does a servo work? I have no idea. So are there steps that you would follow or resources that you would go to help somebody get started with programming electronics, or is it kind of like a no man's land where you just got to figure it out?
I think a little bit of both. It really, what you'll find a lot of the time is once you advance beyond the basics, you'll be looking up how to do this thing, and then you realize that you either can't articulate what you're trying to do, or what you're trying to do is so specific that everyone else's directions don't quite apply to what you're trying to do. But I would say that that's exactly the same as like going on Stack Overflow and trying to solve programming problems, right? Like you'll look and you'll be like, that gets me so close, but there's this other part that no one is mentioning, that no one has like, solved for me when I'm Googling, and you don't kind of have a choice but to figure it out. For me, it's really the same as programming. You break something down into a discrete set of problems, right? So you write down all the things you don't know. I don't know servos. I don't know power management. I don't know this. I don't know that. And then you just have to stay motivated enough to kind of either start with a smaller project or reduce it in scope. Like, I'm going to make the servo do this. And then once that's complete, that's going to be another Lego piece for my greater, larger part. Being able to stay motivated in learning all of those separate parts, it's going to feel exactly the same as when you first started programming. You're just like, why do I have to learn all of these different concepts? But you figured it out, right? You were obviously interested enough. So I think it's a similar project. It just feels really horrible because you've built up all of these skills as like a computer or technical person in general. And then with this, it feels like you're starting from scratch and you feel really dumb. And that can be really demotivating. So I think for me, it's more the psychological stuff than specific tools. But I will say that the Arduino website, if you wanted to start with Arduino, which I would recommend, has so many different tutorials and projects you can follow. And they've tested them, they were written a lot of the time by people who literally work there. So you sort of know what you're getting. And there's no shame in like doing a bunch of basic things that have nothing to do with your project at first, just for you to understand like the foundations of how to solve your problems.
All right. And it seems like a lot of people are recommending using VS Code with the Arduino compiler imported into VS Code. Is that, or do you find using the Arduino IDE is beneficial, or what do you use to interface with that?
Yeah, I think that the VS Code tools now, and VS Code itself is actually a really good tool for doing this stuff. The Arduino extension is actually really good. If you don't want to use VS Code, then I usually recommend people use this thing called Platform.io, which is a Python command line tool that can compile and upload to boards of various architectures. It also kind of it has this prescriptive structure for your directories as well. So as you're learning how to write the code itself, you also are learning how to structure your projects so that they compile very easily and you don't end up with linking problems and things like that, which can be scary issues if you're not used to programming in C and C++. So they're the two sort of, there's the bare bones, which is like Vim or Emacs or whatever, and use the command line tool Platform.io, or use VS Code, which is like an entire integrated environment these days for this kind of thing, which most people tend to go to. If you want something that's like less involved than that, you can also go to create.arduino.cc, and that's actually a browser-based editor. And depending on your operating system, they can natively upload to your Arduino like directly in the browser too, which is actually really cool. So that solves a lot of the library linking problems, because Arduino are just going to have that stuff naturally baked in and easy to use out of the box as well. So the browser can be a really quick way to get started too.
Yeah, I got one of the little IoT devices, the Circuit Playground Express from Adafruit, which using MakeCode, I think in the browser or something like that, was able to download and upload the compiled instructions directly to that. So that was a lot of fun.
Yeah, MakeCode's really good. I like that they have both the Scratch interface, but also like you can go to like JavaScript mode as well, which is pretty cool. I think they're experimenting with like WebUSB in the browser too. So if you set up your device in a certain way, you don't have to do the download upload bit, which is actually really cool too. But yeah, I definitely recommend Microsoft MakeCode, especially for kids that have used Scratch and then they want to actually start doing Scratch for hardware.
Yeah, my son, since we've all been home for a number of days now, he actually surprised me and went to a browser and opened up a coding playground and started dragging and dropping things and making fun little dances. So I haven't been able to get him interested in coding, but he has stumbled across it himself and has found something that is interesting to him. So that's always fun. And to Clayton's question, he tends to overdo a lot of things, which is how we ended up live streaming and restreaming to multiple platforms. And I know you do a fair bit of live coding yourself. Are these types of projects the things that you cover on screen as well?
Oh, I thought that question was to Clayton. I'm sorry.
No, I'm sorry.
Can you repeat?
Yeah. So I know that you've been live streaming for a while now and doing live coding. Are these the types of projects that you cover on your stream as well?
Yes. I actually started live streaming just because I found that people were just continually intimidated by the work that I did in my spare time, which was predominantly hardware. And I was like, it's really not that hard. It's the same as like Kubernetes and machine learning and security, right? It's just like there are these certain topics that just give people the willies. And I think that hardware is like one of them. And I said to them, it's just like programming like a computer with less clock cycles. And if anything, the problems are less complex to think about. They're just in a different paradigm. And so I thought if I stream, maybe people will be like, oh, I can do this. This is like not that bad, right? It's like, and so I did that. And I also wanted more open source contributors to some of my hardware libraries too. And I thought if people actually watch me working with the library, they might become familiar with the code and have the courage to pull request me, which for some projects that worked really well, for others it didn't. So a really popular library that I maintain, well, really popular, is inside of its own niche, is AVR Girl Arduino, which is a JavaScript library that I wrote that allows you to upload compiled code to MXChips. And MXChips feature on things like Arduinos. They feature in mechanical keyboards, in 3D printers and things like that. And in a lot of kind of like 101 beginner hardware kits. So that gets used by quite a few companies, including Arduino, in their Create ID that I talked about, their browser-based ID. And so I maintain that, and people can just watch me doing weird stuff with JavaScript, but it's hardware related. And that definitely was a motivator to me live streaming in the first place.
Very nice.
So we talked about the resources that are over with Arduino, the Arduino resources that Arduino provides. Are there additional resources that you might point out or point people towards if they're trying to get involved in some of like the MXChip tutorials, or just trying to figure out, how to get started or any of that?
Yeah, so with the MXChip, their website is actually really, really good. It has a bunch of projects, including the GIF one that you were talking about, which is a community contributed one. So most of those tutorials are just projects that you can open directly inside VS Code. So you don't even have to, even if you don't know how to use Git, it'll just clone it down for you. It'll set everything up. So I really like that as a resource. If you're sort of confused about how certain sensors work or how to take it one step further, but you feel like, the documentation's not quite there, I definitely recommend Adafruit's website, adafruit.com. Absolutely incredible website by Lamar Fried and the whole company. And their tutorials range everything from how to use certain products of theirs to how does this kind of stuff even work in the first place? Like, what's a resistor? What is a, what does a MOSFET do? And things like that. I also really like SparkFun as well. They have a really, really extensive tutorial base. So those two are really good for generic things like, help, I'm having trouble writing this piece of C++ that, the MXChip website is not going into depth into, or something like that.
Okay. And then to kind of close in a different direction, one of the things we ask sort of everyone that we bring on is to give advice to people that are just getting started. And so I'll kind of leave this a little bit more open-ended to you. You could give advice to people that are just getting started into, the land of software development or hardware IoT. But do you have any words of wisdom to kind of help these listeners kind of get a leg up? And, what would you say to them?
Yeah, I think that the easiest thing when you're first getting started is, the easiest thing that happens is to become overwhelmed. Like, as you learn one thing, you discover that you don't know 100 other things. And I think that for me, it's about motivation. And so if you're struggling for motivation, I genuinely believe that you don't have the right project to get started with. All of the deep learning that I've managed to do, and very rapidly at that, has been through having a project that I'm absolutely super passionate about. So an example like this, I'm super into accessibility. And so when the Xbox adaptive controller came out and I found that you could make your own, peripherals for it, I was like, I have no idea how that works. But I care so much about that as a topic that I want to find out. And it's going to carry me through the dips of despair, I guess you could call it, when you're just like, I'm too dumb to understand this. And so I know it's really cliched advice, but I usually just tell people, please find a project. And it can be the tiniest thing. It can be, Arduino, it can be really, really simple. But then figure out how to actually do it, and then figure out why it works the way that it does, and then sort of move on to the next step up. I just cannot recommend that enough, because when I've just sat down and said, I'm going to learn Golang today, it's never gone super well. The way that I learned Golang was, I said, I really want to write this command line app, and it's going to feel horrible, and all I want to do is reach for Python or JavaScript or something else to do it, but I'm going to force myself to use Golang. And that's where I learned everything from how the language works to the pitfalls of the language. And then I was able to then sort of start comparing it to all the other things that I knew. And that was very, very helpful for me. So that's always my advice, because unless you're excited to learn, you're just going to have so much struggle. And a lot of people just don't realize that, and they assume that they're not interested in coding. But like, if you're interested in the problem itself, it can really help.
Excellent advice. How about for our listeners who may want to just get in touch with you, maybe follow some of your live coding? Where's the best way for them to do that?
Yeah, I'm on Twitter like every day. I probably shouldn't be right now because like the news is not great, but I'm on Twitter. My handle across most of the internet is NoOpCat, so it's NOOPKAT. It's a joke. It means like useless cat or lazy cat. So, so if you go to twitter.com/noopcat, or if you go to twitch.tv/noopcat, then I can be found in those two places. If you want to see some of the custom PCBs that I've designed, I have 2 of them up on my website with photos called, and that's on noopcat.com or noopcat.com. So yeah, I'm pretty, I guess, consistent in handle across the internet.
Nice.
Well, perfect. Thanks, Suz. Really appreciate you taking the time to speak with us today.
Yeah, thanks for having me. It was cool to chat nerdy stuff.
That was Suz Hinton. Suz is a front-end developer by trade, an open source contributor, enthusiast in her spare time. She likes the web, robots, accessibility, education, and code.
If you like this episode, please like, rate, and review on iTunes.
Find show notes, blog posts, and more at sixfiguredev.com.
And be sure to follow us on Twitter at sixfiguredev.
This has been another episode of the Six Figure Developer Podcast, helping others reach their potential. I am John Calloway.
I'm Clayton Hunt.
And I'm John Ash.